Test volume test. Latency test. Test volume test. Latency test. All right. Back at it again. Okay, so it looks like you guys can even see my background, which is good. Oh, this one. Okay, subs come together. Last thing is a test.
Hello everyone, and welcome to the NumPy operations lecture. In this lecture, we're going to show you basic operations you can perform on NumPy arrays.
I don't think the audio is capturing from the right place. Hello, hello. Test, audio test. Let us begin.
Let's go ahead and jump to the Jupyter Notebook to get started. Alright, so here we are at the Jupyter Notebook. We'll go ahead and discuss array with array operations, array with scalar operations, and then some universal array functions, what they are, and how you can find more of them. We'll go ahead and start by saying import numpy as np.
Okay, so you guys are listening for echo. Test. Distance test. Distance test. Distance, 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 distance. I think it's decent enough.
And then I'm going to go ahead and make an array. We'll say np.arrange. And let's just go ahead and go from 0, 11, so that way we get digits 0 through 10, so 11 digits from 0 to 10. Alright, you can easily perform array with array operations just by using simple arithmetic signs that you're already used to from Python itself. So for instance, if you wanted to add two arrays together on an element that you're already 0, 11, so that way we get digits 0 through 10, so 11 digits from 0 to 10. Alright, you can easily perform array with array operations just by using simple arithmetic signs that you're already used to from Python itself. So for instance, if you wanted to add two arrays together on an element by element basis, you would just say array plus array, and that would add the two arrays together. In this case, I'm just adding an array to itself, so essentially every number's been doubled. I can do the same thing for subtraction or even multiplication. I can also perform array with scalar operations in very much the same manner. So scalars mean just a single number, and what NumPy does is it basically broadcasts that number to every element in the array so that operation occurs also on an element by element basis. Meaning if I wanted to, here's my array, add 100 to every element in the array, I could just say plus and then the scalar itself. And that would add 100 to every element in the array. And this also works for multiplication, division, subtraction, you name it. So if I want to subtract 100 from every element in the array, I can just say minus 100. All right, so those are basic arithmetic operations that you can perform with either array on array operations or array with scalar operations. Something I want to show you is that a lot of times NumPy will just issue a warning instead of outputting an error on certain mathematical operations. So for instance, if I try to say 1 divided by 0 in Python, I will get an actual error, a zero division error, which makes sense because you can't divide a number by 0. However, NumPy won't give you the same error. So if I try to say array divided by array, notice the very first element is 0. So I will try to say 0 divided by 0, which doesn't really make sense. However, NumPy will issue a warning. It will say invalid value encountered in true divide here. And it'll just give you a null if you try to divide a 0 by a 0. Everything else is okay. For instance, 1 divided by 1 is 1, 2 divided by 2 is 1 as well, etc., etc. However, on the very first one, 0 divided by 0, it executed and gave you a NaN, or null object, back. It didn't actually provide an error for you, meaning you still get an output. And that's important to note the distinction there. That means if you have this sort of operation in your code, you actually won't get an error, the code will continue to run, and instead you'll just receive a warning. If you try to do an operation that divides maybe another number by 0, so for instance 1 divided by 0 instead of 0 divided by 0, you'll also get a warning, but in this case it'll actually show infinity instead of a null. So again, you get a divide by 0 encountered in true divide warning here. However, it still executes the code, and you get INF to signify infinity for the 1 divided by 0 at that very first element. Alright, so that's something to keep in mind as you're working with division and arrays that contain a number or digit 0. And also a quick note is you can also do arrays with exponents by just saying asterisk asterisk, just like you would with Python, and then either the scalar or the array you want. So this is the array to the power of 2. So everything has been squared in the array. Now let's discuss universal array function. NumPy comes with many universal array functions, which are essentially just mathematical operations you can use to perform the operation and broadcast it across the entire array. Let's go ahead and show some common ones. For instance, if you want to take the square root of every element in an array, you can just say np.sqrt and then pass in the array itself. And this will take the square root of everything in the array. Similarly, for calculating the exponential, you can say np.exp and pass in the array. For maximum, you can either say the array.max, or you could also say np.max and pass in the array. That's the same thing as calling the method off of it, which we've seen earlier in the very first lecture on NumPy arrays. You can even do trigonometric functions such as sine, and this will basically pass in every element into sine. And there's cosine, and there's also logarithm. Arithmetic options, so you can say np.log, and if something doesn't work, for instance the log of 0 is technically negative infinity, you'll actually receive a runtime warning divided by 0, but it will give you negative infinity as the answer. If you're wondering where you can find a list of all these universal array functions to reference, you can go ahead and check out the notebook, and it has a link in there for the universal array functions, and it will take you to a link that looks like this. This is the NumPy array documentation here for universal functions, or ufunc. And if you scroll down to the bottom of this page, and again this link is in the notebook for this lecture, NumPy operations, you'll see a whole list of all the universal functions you have available for you. So you have basic math operations, add, subtract, absolute, remainder, etc., log. trigonometric functions, and then some more advanced functions, such as comparison functions, maximum, minimums, floating functions, etc. If it's a very basic or common mathematical function, you should probably visit this page first and see if NumPy already has it built in before you start creating your own function to deal with that particular mathematical operation you were trying to perform on your array. We'll only deal with the very basic ones throughout the course, and we'll remind you as we encounter them throughout the rest of the course. Okay, that's really all there is as far as basic operations on arrays. You can just use basic arithmetic either on an array by array basis or with an array and a scalar basis. The only thing to watch out for is if you have a 0 and you're using division with your arrays. Then the second part of this lecture just covered universal array functions, where to find them, and to keep in mind that most common mathematical operations. Hello everyone, welcome to the NumPy exercises overview lecture. In this brief lecture, we're going to quickly go over the exercise questions and how to approach them. Then, you'll go ahead and perform the exercises, see if you can solve them, and after that, we'll have a lecture on the solutions. Let's go ahead and jump to the exercise notebook and quickly go over the questions. Alright, here we are at the NumPy exercises notebook. What you're going to go ahead and do is just answer the questions or follow the instructions in bold. And you'll see that there's actually output arrays for you, or output answers for you, which are the answers you should get. Keep in mind that if you actually run the cell that has the direct output below, you will overwrite the output. So for instance, if you're saying create an array of 10 zeros, hopefully you remember from the lectures how to do that. But if you have code here, such as print hello, and run that code, you will no longer see this output. So keep that in mind as you're running through these exercises. All right, so basically we'll start off with asking you how to create some arrays, some array of integers, some array of identity matrices, 3x3 matrix, etc., some random number matrices, and then I'll ask you to create this following matrix. So keep in mind that you should insert cells here in order to not delete the output. Then I'll ask you to create an array of 20 linearly spaced points between 0 and 1. So just go ahead and follow the instructions here and pay careful attention to not overwrite the output if you're not ready to overwrite it yet. Then we'll talk about NumPy indexing and selection, where I'll give you a few matrices. In this case, it's just actually one matrix, this 1 through 25. It's a 5x5 matrix, and I will ask you to grab chunks from that matrix. And notice here, I have given you an extra cell since these are a little trickier and you need the reference. So go ahead and write your code here, and that reproduces the output in the cell below. And be careful not to actually write your code here, otherwise you'll overwrite the output that you're trying to replicate. And if you get it wrong the first time, you don't remember what you're actually trying to answer. So again, just write the code here in these cells, that way you don't overwrite the output itself. Okay, and then through those exercises, you're just going to be trying to grab the chunks shown here as the answers. Then, in that same matrix, or that reference that's shown here as the answers. Okay, that way you don't overwrite what you're actually trying to replicate. And if you get it wrong the first time, and be careful not to the reference. So go ahead and write your code here, and that reproduces the output in the cell below. And be careful not to actually write your code here, otherwise you'll overwrite the output that you're trying to replicate. And if you get it wrong the first time, you don't remember what you're actually trying to answer. So again, just write the code here in these cells, that way you don't overwrite the output itself. Okay, and then through those exercises, you're just going to be trying to grab the chunks shown here as the answers. Then, in that same matrix, or that...
All right, cool. Yeah, I'm going to just do it in a completely new tab. Just because I feel like working on it completely fresh. I think I'm going to do completely fresh. Question is, can you guys see? Can you see? Oops. Give the stream a second for me to catch up to it. And the answer is no. You cannot see this. Okay. Okay, let's do these questions. Exercises. Okay, import numpy as np. Will do. Import numpy as np. Cool. All right. Create an array of zeros, 10 zeros. np dot zeros 10. I believe that's how you do it. Yeah. Create an array of 10 ones. Okay. np dot ones 10. Okay, create an array of 10 fives. Wow, I don't think that's a thing. I don't think that's a thing. Like if it's like fives. Yeah, no, that's not a thing. Array 5, 10, maybe. Uh, create an array of 10 fives. Let's go back to our notes.
Output for np.i. Say 1 to 1 function centered around 0. RAND. And this is going to create and cover a few ways to do that. What you're going to go ahead and do is call np. You can tell it's one-dimensional, okay, or a tuple. One way you'll probably be creating a numpy array is using np.arrange. And this is really similar to Python's own built-in range. Step size is a third. If I just say from Python's range, I'll get an array back from 0, 7, 8, 9. So unlike the previous functions we worked with, instead of passing in a tuple, I'll actually just pass in the dimensions as separate arguments. So that means rand n. So for a 4, from a low to a high, and 10 there, and there are 10 random integers, inclusive on the low end and exclusive on the high end. Okay, let's go ahead and discuss just a few useful attributes and methods of an array. And then I'm going to say ran r is, all right, I can reshape it as a 5 is equal to 25, and I know I get the minimum value of your array. You can say argmin, and it will return the index location of the minimum value. So I'm going to say attribute I want to show for now, return.
All right. Well, I don't think I know. Array of 10 fives. How to create np array of same number. Full. I mean, I think he showed us that. Full. 5, 10. Okay, 10, 5. Side length of 10. Value of 5. Cool, that works. An array of the integers from 10 to 50. I slightly remember. Slightly remember. Oh, no double R. You just need another spell. 10 to 51. An array of all even integers from 10 to 50. All even integers. So increment by 2. So we can do the same thing. NP. Do it again. NP dot range. Come on. 10 to 51. Increment by 2. 10, 12, 14, 16, blah, 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 to 50. Let's check our answer. Cool. Create a 3 matrix of values ranging from 0 to 8. Here's a question, though, right? We know how to make a 3 by 3 matrix, right? How do you make the range of values? Um, let's go ahead and get it wrong real quick. mp dot array. Um, should make a 0 to 8. It's 2D. So it's gonna be 3 by 3 by 3. Or 3 by it's gonna be 3 by 3. Okay, 3 by 3. Um, let's see what that does. Okay. Oof.
There's other functions in number to represent the number of columns. So in a third argument 10, and this returns back a one-dimensional vector noted by the one set of brackets here. 3 dimensions will have 3 brackets, etc. All right, so that's lint space. Again, don't confuse lint space with arrange. All right, moving along of the given shape you pass in, and it's going to populate it with random samples from a uniform distribution. Instead, from a standard normal from 1 to fill up that matrix completely. So for example, if I want, and I pass in the new dimensions I want. So for example, if I want to reshape that, and it's going to be ran lectures.
I mean, if I just want to hard code it, right? And make the array, right? Let's do 1, 2, 3. Say 0, 1, 2, 3, 4, 5, 6, 7, 8. And then, oh, yes. To identify it. And P. Wait, here we go. Okay, look, that works, right? But can we just make the size and fill it with values that we want? That's the question. I don't think I ever got a shot at it. Oh, see the full function. We're coming back to it. NP dot full, and we're gonna have a three, a by three. Okay, we're gonna have the values 0 to 8, which means we're gonna go up to 9. Maybe that works. Let's check. Okay, invalid syntax. Do 0 to 9 like this. Or does that only check values of the index? All right, here's the question. How do we fill it? Full. Oh, see, this is, you just create a matrix. There's literally a function. No, they're making up something. No kidding. Hold on. np dot arrange 1 to 10 dot reshape to be a 3 by 3. Like, spelling. Nice. Is that what we wanted? 0 to 8, 3 by 3 identity nature. Okay, 3 by 3, 0 to 8. Nice, cool. That's cute. Okay, now let's make an identity matrix. 3 by 3 identity matrix. I don't remember if I call that. If I had to give a guess, it'd be an NP identity. I. It's literally I. NP dot I. And then 3 by 3. So it's just gonna be a 3. It's gonna be even. Okay. Yeah. Use numpy to generate a random number between 0 and 1. NP dot rand. I don't know if it's rand. Random. Nope. Rand int. Trying to remember this stuff.
And cover a few ways to go to 1. And that means
NP random dot rand. Okay. Okay, well, this is going to fill an array with random numbers of a specific range. So, random numbers between 0 and 1. A random number between 0 and 1.
Means if I want just a one-dimensional array of random numbers uniformly distributed from 0 to 1, I can pass in a single digit and I'll get back that one-dimensional array.
Oh. How many questions we got? 53, so like 20, like 16 maybe. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20. I didn't really count. Okay. It's late. I lost track. Use NumPy to generate an array of 25 numbers sampled from a standard normal distribution. Oh, okay. I kind of remember where he was talking about this. Don't remember the thing though. So the whole gist of this, yeah, don't barely remember what he was talking about.
If I want this to be two-dimensional, unlike the previous functions we worked with, instead of passing in a tuple, I'll actually just pass in the dimensions as separate arguments. So that means if I want a 5 by 5 matrix of random numbers, I just pass in 5, 5 instead of the tuple when working with these random libraries. All right, if we want to return a sample or many samples from the standard normal distribution or a Gaussian distribution, instead of using rand, we can use randn. And that means I can say np.random.randn, and this will return numbers not from a uniform distribution from 0 to 1, but instead from a standard normal distribution centered around 0. And that means I can go ahead and pass in 2, and I get 2 random numbers from a standard normal distribution. And later on we'll see that plotting these out, not in this lecture, but once we get to data visualization, we'll go ahead and show you a nice normal distribution curve or a Gaussian distribution curve. And again, if I want this to be two-dimensional, I can just pass in 2 dimensions. So for a 4 by 4, I say 4, 4. And no, I don't pass the tuple here, I just pass in each dimension as a separate argument, and I can see by the set of 2 brackets that this is a 2-dimensional matrix as an output. And the final random method of creating an array we're going to learn about is randint, and that returns random integers from a low to a high number. I'll go ahead and show you what we can do for that. You'll go ahead and say np.random, pass in rand int. You'll pass in, if I go ahead and click Shift Tab here, a low, a high, and then the actual size you want. So for instance, if you just say 1 to 100, you'll get a random integer between 1 and 100. And the low is inclusive and the high is exclusive, meaning 1 has the chance of being selected.
Okay, so we did it right. Create the following matrix. Okay, so this goes from 0 to 1, broken up 100 times. So how do you write that? A range? Question mark? No. NP dot line space. that what it is? Repeat dot line space. And then we're gonna do 0 to 1 incremented 100 times. No, it's not edit. What the heck? Lens space. Well, not exactly, right? Yeah, not exactly 0. 1, 2, 3, 4, 5, 6, 7. Nah, no, that's not what I'm looking for. Technically, if you round it to the nearest tenth,
0 to 5, I can just pass that in, and that returns a much larger, that there's only 3 brackets, etc. A range will take in that argument as the step size you want. And then you just pass in the random one-dimensional in a tuple, I'll actually distribution from 0 to 4, 4. In order to do this, got to put a D there.
all right. Looks like we're gonna string together some stuff. Yeah. Zero, one, increment by. Firstly, do that, right? But since we have 100, we're gonna make it a 10 by 10. No, it's like sort. Am I clicking? Can't spell a range. Firstly,
And this is noted by the of the dimensions you want. If you want, and in Python's range, it's a number. So,
space.
and that's the random.
I used it earlier. What is it? Reshape. Does this count, sir? 0.01. So we start at 0.01. Yeah, we didn't get the. We didn't get the Bucky boy, huh? It counts, right? Oh God. Okay. Create an array of 20 linearly spaced points between 0 and 1. Linearly spaced points between. Okay. literally. Oh, that's lens space. So it stands for linearly space between zero. Indexing selection. Now you'll be given a few matrices and be asked to replace the resulting matrix output. Arrange. Write the code here that reproduces the output of the cell below. Speed. Oh, okay, I see. Alright, so I'm gonna do it here. Just because it's easier. Alright. Oh, okay. So taking this corner, taking this corner right here, this chunk between 12 and 25, not including 16 and 21. Oh, so if not run this away. So in order to do that, you have to do mat. What is it? It's like slices. Slice. Mat. I'm gonna call it slice equals mat dot. No, it's an array, right? So we're gonna do separate it by. It's gonna do columns and rows, right? So we need columns. We're gonna go column from 1 over 1 this way, and then the row we're gonna do it from 0 1 1 over. So we're gonna do 0 1 2 over. Oof, doesn't feel right. Invalid syntax. Sure. Let's do that. See what happens. Yeah, still invalid syntax. Well, then I think we should give up. I think we should burn the computer. Burn it all down.
5, 6, 7, 8, 9, 10. Because remember, index 5 is actually here at 4.
Ooh, I tweaked. Not even using correct brackets. See if that does something. Okay. Wow. That is not defined. That's right here. How's it defined? NP is not defined. Let's run NP. We'll run NP. Import numpy as in NP. Fair enough. Cool. Let's do this one. Oop. Let's run it. Cool. Wrong freaking thing. Okay, so what we get here? We got 8, 9, 10, 11, 12, 13. All right. We need to squish it down by 1. Move it over to the left by 1. All right, so what does that tell us? Columns, right? Columns start from 1 and gives everything over. So I guess we have to do that 0, right? And this is 2, 2, and it gives 3. Did I get there? Did I get everything backwards? I did. did get everything backwards. So that's rows, that's columns. Okay. So since this is rows, yeah, I guess. All right, write the code here that reproduces the output of the cell below. 2A. Reproduce 2A. Matt. Go back up here, right? Do Matt slice too. I'll just do Matt. Matt is gonna be 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 3. Complete. 1, 2, 3, 4. 0, 1, 0. 1, 2, 3, 4. 0, 1, 2, 3, 4, 5. 0, 1, 5, 3. It's leaking right now. Hold on, this is embarrassing. All right, let's figure out what's what. Matt 1. 6, 7, 8, 9, 10. Okay, just gonna use the entire row. This is row 0. 1, 2, 3, 4, 5. Cool. Now row and then column. 1, 3. Let's hop down. So we're at 3, 4, 5, 4. To 0, 1, 2. Took way too much brain power. Next. Oh boy. Do we want to do all of these? Nope. We're gonna maybe. All right, let's get the outputs. 2, 7, and 12. Where is that? 2, 7, 12. That is literally the most awkward thing ever. Okay. So we want row 0, 1, and 2. But we want column 1. What do we get? What do we just do? 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. What is this? How do we? How did we get this? How did we get this? Okay. 6, 7, 8, 9, 10. It's very curious to me right now. Immediately, I don't see how that doesn't work. Okay. Um, 1, 2, 3, 4, 5. So on the second slide, now we're getting to rows. Row, row, row. I want rows up until row 0. 1, 2. Now, what do I want? Only give me column 1, 6, 7. Yeah, still tweaking. Um, mm, oops. I'm too tired for this one. I'll come back to this. I'm way too tired for this one. Get the sum of all the things. All the things. My tired brain is not comprehending how this one works.
I've actually changed 99, not just on the slice, that slice of the array. Here I have the array 0, 1, 2, 3, 4, 5. And I want to show you an important note on slices of an array. If I go ahead and create a variable called slice underscore of underscore r for array, and I set it equal to a slice of the array, for instance, 0, 6. So let's go ahead and see that slice of the array. Here I have the array 0, 1, 2, 3, 4, 5. Basically, that first chunk. That means I'm grabbing everything in that slice. If I try to broadcast this to be another number, such as 90, the original array, meaning the data is not copied, it's just, if I take a look at my array copy, slice of the array is known as a matrix, and I'm going to the array, and here I have in the very first column, and just do a 5, 10, 50 elements, places from this matrix, up to call a row to corner, meaning I want to say 10, 15, and 25, 30. So this top right corner here is what I want to grab. What I can go ahead and do is use slice notation in order to do this. So I can say grab everything up to call a row 2, and then grab from column 1 onwards. And that returns 10, 15, 25, 30. Let me go ahead and break this down one more time. As far as the rows, what we're saying is grab everything but not including rows 0 and 1 as the colon, but then don't include 2. So I'm saying slice to 2. And I'll go ahead and show that as just a single command. So if I say colon to 2, that returns these 2 rows.
It's just like making less and less sense. I'm not gonna lie.
row 0, and row all the way to the end, which basically as just sections, for instance, 20, 25, 30, and 35, 40 index slicing. So if this is confusing to you, you don't have to worry about it too much since we won't really actually do it that often throughout the course. We'll usually pull Boolean array out of this. Right now, and more common, a little weird at first.
Already call the represents the output this up below. 20 to
Making stuff up. Hmm. Hmm. Well, all right then. I think I'm gonna call it a night. After we take a sneak peek at what the future holds. All right, so we gotta do pandas, matplotlib, seaborn, and geographical plotting. Then we get into some actual math.
Congratulations on completing the NumPy section of this course.
Sure.
Coming up next is the Pandas library section. Pandas is one of my favorite tools, and it's a powerful resource for you as a data scientist. Let's go ahead and get started, and I'll see you at the next lecture.
Hello and welcome to the Introduction to Pandas lecture. In this lecture, we're going to briefly discuss what Pandas is, how to get it installed onto your computer, and what to expect throughout this section of the course. Pandas is an open source library that's built on top of NumPy, which is why we learned about NumPy first. Pandas allows for fast analysis and data cleaning and preparation. A lot of people like to call Pandas Python's version of Excel, or if you're familiar with R, Python's version of R data frames. Python and Pandas really excels in performance and productivity for the user. Pandas also has built-in data visualization features, which we'll learn about once we get to Python for data visualization. Pandas can also work with data from a wide variety of sources. You'll need to install Pandas by going to your command line or terminal, and then use either conda install pandas if you have the Anaconda distribution of Python, or if you installed Python through a different method, you can also use pip install pandas. Either one should work for you. As far as what to expect throughout this section of the course, we'll first discuss series and how they interact with pandas. Then we'll build on top of that to go to data frames with pandas. Then we'll discuss some particular topics, such as working with missing data, how to use group by with pandas, merging, joining, and concatenating data frames with pandas, various pandas operations, and then how to get data in and out of pandas for a wide variety of formats, such as CSV files, Excel files, SQL, and more. All right, let's go ahead and get started with pandas. Thanks, and I'll see you at the next lecture. Hello everyone, and welcome to the series lecture. Series are going to be the first main data type that we'll be working with pandas, and then we'll build off of series to work with data frames in the next lecture. Let's go ahead and get started by jumping to the Jupyter Notebook. All right, here I am at the Jupyter Notebook. A series is very similar to a NumPy array. In fact, it's actually built on top of a NumPy array object, but what differentiates the NumPy array from a pandas series is that a series can have access labels, meaning it can be indexed by a label. Let's go ahead and say import NumPy as NP, and then I will import pandas as PD. And what we're going to start off with is creating various series from various object types. I'm going to make 4 Python objects. I'll create a list called labels, and this will just be 3 letters or 3 strings in a list, A, B, and C. Then I'm going to go ahead and make a list called my underscore data, and I will say it's 10, 20, 30. Then I will create an object called ARR, and this will be a NumPy array, and I'll just pass in my data. So one is a Python list, and another is a NumPy array. And then finally, as a dictionary, I will pass in A as a key, 10 as a value, B as a key, 20 as a value, and then C as a key, and 30 as a value. And that means I have 4 separate Python objects. I have labels, my list, and then I have my data, I have my array, and then finally, I have my dictionary. Okay, let's show you how you can create a series and what it actually looks like. You can say pd.series, and note here, I'm not actually saving the series to any variable name, I'm just using pd.series. But if you do Shift Tab here, you'll notice PD series takes a wide variety of parameters. We're just going to focus right now on the data and the index, which are the most important ones. First off, we'll just pass in data, and we'll set that equal to my underscore data. We'll just pass in that list. And note here, I get my series back. And it looks a lot like a NumPy array, except here it's very distinguished that we have an index, 0, 1, 2, and then the actual data, 10, 20, 30. And the key to a pandas series is that you can actually specify what you want that index to be. For instance, I'm going to go ahead and say pd.series. I will pass in data equal to my data, and then I will specify that the index is equal to labels. And remember, that's A, B, and C up here. So when I run this, now I have a labeled index series. So I have A as the label, or the index, and then 10 as the actual data point for that index. So unlike a NumPy array, I actually have a labeled index series. I will pass in data equal to my data, and then I will specify that the index is equal to labels. And remember, that's A, B, and C up here. So when I run this, now I have a labeled index series. So I have A as the label, or the index, and then 10 as the actual data point for that index. So unlike a NumPy array, I actually have index that are labeled, meaning I can call these data points using this labeled index. And just as a quick note, since data and index are actually in order as far as placing them in as parameters, you don't have to say data equals or index equals. You could just say my data and then labels as such, and you would also get out a series in the same manner. So you don't need to constantly specify data equals or index equals, as long as you put them in the correct order. All right, let's go ahead and show you a couple more ways to create a series before we actually start working with data in a series. Another quick way to create a series is by saying pd.series, and you can pass in a NumPy array. And this is going to work exactly the same as a Python list. So here I pass in the NumPy array, and it worked the same way. And just like the list, I could have also passed in labels along with this NumPy array. So essentially, a NumPy array is going to work the same thing as a Python list as far as passing it into a series. And then finally, what's really cool is you can say pd series and just pass in a dictionary. And what Pandas is going to do is it's going to automatically take the keys of that dictionary. Let me just go ahead and show it here again. Take the keys of that dictionary, set it as an index, and then set the value of that key to the corresponding data point. So that's a nice, fast way to quickly create a series. All right, something to note here, and another thing that differentiates a NumPy array from a Pandas series, is that a Pandas series can actually hold a variety of object types. Right now, we've shown a Pandas series, pd.series, holding just numbers. So for instance, I've shown it holding just an array of numbers, but it could have also hold, as the data, labels itself, which remember is labels, if I go ahead and run this here, is just strings. So a series can actually hold pretty much almost any type of data object with Python as its data point. So it can be strings, and even more interesting than that, we could say data equals, and you could have actually passed in built-in functions. So I could say something like sum, print, len, and it's actually holding references to these built-in functions as data points in this Pandas series. And that's not something you can do with a NumPy array. Now, I have index labels, and 1, 2, 3, 4 are my data points. And note, it'll say d-type integer 64, since my actual data points are all integer. This is your actual index. All right. Usually your index is going to be 4.0, and then where it didn't find the match, it went ahead and put in a null value, an array of numbers.
All right, that's a little sneak peek. That looks interesting. It's gonna be a long one. Pandas is about to be long. Oh, there's two parts to pandas. It's a whole exercises joint.
Hello, I'll describe our approach to geographical plotting for this course. By its nature, geographical plotting is usually very challenging due to the various formats the data can come in, and a lot of times you have to find a specific library to work with for your specific data source. For this course, we're going to focus on using Plotly for plotting since we've worked with it in the past, but I should also note that Matplotlib also has a base map extension which allows for you to create static geographical plots using Matplotlib. We're going to focus on Plotly due to its interactive visualization capabilities. All right, so let's go ahead and get started with geographical plotting by learning how to use Plotly to create these choropleth plots. Thanks everyone, and I'll see you at the next lecture. Information either on a global scale or on a national PY. And then I'm going to say, in order to do level, and there's various location mode, and you can type in all these quotes and not having to make all these strings for key. The predefined strings shown in your notebook. For instance, we can go ahead and change this to choromat, equal to layout. We don't technically need to actually pass in data equals and layout equals. We could just pass Portland color chart chosen here. And we can go ahead and change it to one of the predefined strings shown in your notebook, match up. Then the data.
She's fascinating. All right, we get into here. Jeez. right. Good session.